Good. So now let's talk about inequalities. Okay, not much, Shahina, just here to give you some idea about inequalities. Okay, more about inequalities we will talk later, maybe in our intensive math course level 2. Now what we are doing here is level 1. Okay, after we finish these topics, now we are going to cover like 7 different topics here. If we could finish everything is okay, then we will start level 2. All right, at that time we will see inequalities once again in detail. Now just here, I'm going to give you some brief information about inequality and the difference between equation and inequality, okay? For example, number 1, where should we use the inequality? In what situations in real life, okay? And a lot of times, actually, what we mention, like for example, this movie is suitable for the students or people who are above 13 years old, for example, right? Or your father says that, okay, Shahina, I will give you pocket money, but at school you should spend maximum $10 a day, for example. All right. Another one is in Uzbekistan, the population is less than, or it does not exceed $50 million, for example. Okay. And you are going to organize a party, you're going to spend some money, right? You're going to buy maybe drinks and the cake and some cups, whatever it is, decoration stuff. And your father says that, all right, you can spend some money, but spend not more than $50. All right, in this kind of situations, we do not use equal sign. We use special sign that we call this inequality signs. In math, we have 4 different inequality signs, right? The first one is greater than, right? That we use this greater than. The second one is less than. Third one is greater than or equal to. This is how it is, greater than, less than, greater than or equal to. And the last one is less than or equal to. When we talk about inequalities, we mean that one of these symbols, right? Actually, they are involved in our problem. Okay. For example, here, one example. Let's say this N is the age of people. You just pick anybody, for example, in a town or anywhere. If there's a ad here, it says that there's a movie, it says that it is 13 plus. What does it mean? To be able to watch this movie, your age, right? Anybody's age, this N should be greater than or equal to 13. We mean this. That means that if you are 13 years old, you are actually allowed to watch this movie. If you are 14, 15, 19, 20, 50, how many solutions do we have? We have a lot, right? Any number which is greater than or equal to 13, it satisfies this condition, okay? I cannot say here that equal. If you say equal, we are talking about only a single number, all right? Now, actually, if I want to show this on the number line, how do you show this? Here we have number line. Here we have 0, 1, 2, 3, 4, 5. And here we have 13, right? And all the numbers actually to the right of 13, right? We are talking about these things. So this arrowhead shows that all the numbers here, it satisfies this inequality. When we solve equation, for example, we solve one solution, right? We find one solution. But inequalities, it has infinitely or a lot of solutions. That's why this is one way of showing the inequality. This one is the another way, all right? And third way is in solution set form. How do you show this? Like from 13 to positive infinity. Okay, this thing is not so important, but here we will focus on this part. Okay, this is the second one. That's the first, second, and third. The second and third, we will talk about these things later. Okay, this is how should we understand. On the number line also, we know that if you pick any number here, let's say 8, all right. Number 1, if I tell you, Shahina, if I give you another number, which is greater than 8. So where can we place this number? To the right of A or to the left of A?
Right.
To the right, right? Because any number to the right of A, it is greater than A. So B is means it is somewhere here. Now, if I give you another number, how about this? C is less than A. So where is this? Where can I place this C? It is to the right of 8 or to the left of 8. So it is less than, right? So it should be somewhere here. Okay? And how about solving inequality? Solving inequality is very similar to solving equations. For example, if I tell you, Shahina, solve this inequality. 2x plus 1 is greater than, let's say, 7. How do you solve this? Assume that here we have equal sign. So I need to eliminate this thing, right? So if you subtract the same thing from both sides, nothing changes. Here, if I subtract negative 1, and here we have 7 minus 1. These two things are gone. So here we have 2x is greater than 7 minus 1. It is 3. Now, if I multiply both sides by positive number, 1 over 2, 1 over 2. 1 over 2 times 2, it is x greater than 3 times 1 over 2, it is 3 over 2. That means that any number that is greater than 3 over 2 will satisfy this inequality. Is it true? For example, pick any number. Here we have 3 over 2. Can you tell me one number that is greater than 3 over 2?
8.
8, for example, 8 somewhere here, right? So that means that since it is greater, it must satisfy this inequality. Substitute here. If you substitute into this inequality, for example, right, 2 times 8, because we are saying that 8 is the solution, one of the solution of this inequality, plus 1, and greater than 7. 2 times 8, 16. 16 plus 1, 17. Is 17 greater than 7?
Yes.
Yes, that means that that's correct, right? That's the solution. And if you pick any number greater than 3 over 2, pick any number, substitute here, this will be true. But if you pick any number to the left of this number, for example, what number is less than this? For example, let's say 1. If you take this 1, it will not be the solution. Substitute here, 2 times 1 plus 1, which is equal to 3. Is 3 greater than 7? No, that is incorrect. Okay. All right, Sahina, now we'll do very simple questions here. Copy and fill in the blanks with less than, equal, or greater than to make each of the following statements true. You just tell me, I'll write it down for you. 9 and 3. What should we put here? Greater than or less than or equal?
The arrow that's pointing like that, is that greater or
Greater. So you should say 9 is greater than 3, right? Second, question B.
13 is greater than 7.
No, you should start from here. 7 comes first, right? 7 is
7 is less than 13.
Less than 13. See?
Negative 3 is less than 2.
Negative 3 is less than 2. 3 squared?
3 squared is less than 9.
What is 3 squared?
Does that mean 3 times 2?
No. Shahina, you are scaring me. 3 squared means 3 times 3, which is equal to 9.
Oh, that's equal to 3 squared.
So it is 3 squared is 9. So they are equal to each other, right? Negative 4, negative 2. Which one is greater?
Negative 4 is less than negative 2.
Negative 4 is less than negative 2 because it is to the left of negative 2 on the number line, right? Because here we have number line here. If we have negative 2 here, negative 4 is somewhere here. Negative 2, negative 3, negative 4, negative 5. It is to the left of negative 2. That's why negative 4 is less than negative 2. Okay. So in this kind of expressions, first we have to simplify. Then we can compare. What is negative 6 times 0?
0.
What is 7 times 0?
0.
So what can you say about these two things?
They're both equal.
They are both equal, right, to each other. All right. And how about G? 0.4 squared, 0.2. Which one is greater?
0.2. Wait, no. 0.4.
Now, first to do this, Shahina, we have to evaluate. I don't know which one is greater. What does 0.4 squared mean? That means 4 over 10 squared. It means this, right? That is equal to 4 squared, 16 over 10 squared, it is 100. How about the second number? 0.2 means 2 over 10. If you multiply numerator and denominator by 10, here we have 20, here we have 100. Now I can compare here 16 over 100 and 20 over 100. Which one is greater?
0.2.
0.2, right? So here 0.4 squared is less than 0.2. H? We have to evaluate, right? What is negative 5 squared?
25, negative 25.
No, just 25.
Oh.
Negative 5 squared means, negative 5 squared means negative 5 and multiplied by itself. Negative, negative, positive. 5, 5, 25, right?
Mm-hmm.
So this is 25. What is negative 4 squared?
16.
So here we have 25, here we have 16. So which one is greater? What should I put here? Less than or equal or greater than?
Negative 5 is greater than negative 4 over 2.
No, not negative 5. You should read here negative 5 squared is greater than negative 4 squared. Because this thing equals 25, this thing equals 16. 25 is greater than 16. That's why.
Mm-hmm.
Okay. How about I? So Shahina, you should evaluate here. First, negative 0.5 squared equals, what is 0.5? It is 0.5, right? That is minus 1 over 2 squared, which is equal to, or, okay, here we have 0.0. Without this, I can write it. This one is negative 5 over 10 squared. Minus squared is always positive because negative 5 times negative 5, it is 25. 10 times 10 is 10 squared, that is 100. And how about on the right-hand side? On the right-hand side, we have minus 0.4 squared. That is minus 4 over 10 squared, right? Which is equal to minus 4 squared. That means minus 4 times minus 4. That is 16 over 10 squared. It is 100. Now on the left, we have 25 over 100. On the right, we have 16 over 100, right? So which one is, what should I put here? Which one is greater?
Negative 0.5 square is greater than negative 0.4 square.
So I should put here this, right? It is greater than this. Very good. Next, Shahina, what is square root of 6, square root of 8? Which one is greater?
I forgot what the quarter meant again.
These are just the same thing. I can remove this. Which one is greater, 6 or 8?
8.
So here, square root of 6 is less than square root of 8.
Oh, but what do they mean?
This means roots. This means that square root of 6 means, okay, that means that's, look, let me just write something like this. X squared is equal to 6, okay? Now, if I ask a question, what numbers square is equal to 6, okay? We cannot answer this question. That's why we have to introduce this symbol. That means that square root of 6 squared is equal to 6, okay? So this one is square root, like for example, square root of 25. What does it mean? It means that what number's square is 25? So what number square is 25?
Can you repeat that?
Here we have square root of 25. I'm saying that this means that what number's square is equal to 25?
5.
It's 5, right? Similar to this, for example, let me just write at the top, like square root of 9. What does it mean? It means what number's square is equal to 9? So that means 3, right? Because 3 squared is not 3 squared is 9. So square root of 9 is equal to 3. Like, for example, square root of 4, that is equal to 2, because 2 squared is equal to 4. Okay? Like, square root of 100 is equal to 10, because 10 squared is equal to 100. Okay? And that's why, that means that if we just square both sides, we can do the same thing because both are positive. Now we will have here 0.6, 0.8. Which one is greater? This thing, right? So 0.6 is less than 0.8. Next, what is 3 times 0?
0.
Negative 24 times 0?
0.
So these things are?
They are both equal.
Equal. Okay. How about here? 0.3 squared, negative 0.3 squared.
That's going to equal 9.
They are equal.
Yeah, they're equal.
You know why? Because let me just write here, 0.3 squared means 3 over 10 squared. That's equal to 3 squared, 9, 10 squared, 100. Another one is negative 0.3 squared. What does it mean? It means minus 3 over 10 squared. This square means this number should be must be multiplied by itself. That means it is something like this, minus 3 over 10 times minus 3 over 10. And equals, what is negative 3 times negative 3? It is 9. And 10 times 10, it is 100. Did we get the same result? Are they equal?
Yes.
So these things are equal. Because of the square, this negative will be plus. And how about this? 0.2 squared, 0.2 cubed. Again, let me just do here because we don't have enough space. Here we have 0.2 squared. Again, using this, that means that we know that this decimal, that is 2 over 10, right? It is squared. That means 2 times 2, it is 4. This means 10 times 10, it is 100. How about the second number, 0.2 cubed? This means that this something cubed means this number is multiplied by itself 3 times. Okay? So using this a cubed means this a is multiplied by 3 times, because if number is multiplied by 3 times in a short form, in a compact form, we can just write in this form, okay? So here 0.2 cubed, what does it mean? It means 2 over 10 cubed, which is equal to 2 over 10 times 2 over 10 times 2 over 10. Now we know how to multiply fractions, right? 2 times 2, 4. 4 times 2,
8.
8. 10 times 10,
100.
100 times 10,
1,000.
1,000. To compare these two numbers, they must have the same denominators, right? So here we have 1,000, and how about here we have 100? How can I have 1,000 here? Multiply numerator and denominator by 10. So here we have 1,000, 4 times 10, it is 40, right? So I can write here on the left, we have 0.2 squared, that is 40 over 1,000. And on the right hand side, we have 0.2 cubed, which is equal to 8 over 1000. Now tell me, which one is greater here?
40 over 1000.
This is greater, right? The same numbers, we can just ignore them and compare their numerators. 40 is greater than 8. Then here we have 0.2 squared is greater than 0.2 cubed. Okay?
Squared,
How about next? 1.2 squared, 1.2 cubed. Actually here, if you notice here, Shahina, this number is 0.2. Is it greater than 1 or less than 1?
Less.
Less than 1, right? 0.2 is less than 1. How about here, 0.2, also less than 1?
Mm-hmm.
It gets smaller and smaller. And how about this thing? Can you do it?
I think so. 1, 2 over 10 plus 2. This one is 1 over 10. That is 3 plus 2, 10 times 1. 10 is equals 2, 2, 2. Seconds 10 is 100, 40. Okay, I think the 1.2 over 2 is greater.
Over 2?
Yeah.
What do you mean over 2?
No, not over 2.
Squared.
1.2 squared 2
Uh-huh.
is greater than 1.2 squared 3.
Cube.
Cube, yeah.
You mean like this?
Yeah.
It's wrong.
It's wrong? Wait, what?
Yeah. Look here. Rahina, let me just add one more slide here.
Mm-mm.
Okay, 1.2 squared, right? 1.2 cubed. So here we have 1.2 squared. And here we have on the right-hand side, let's say 1.2 cubed, right? So this means equals 1.2 is 12 over 10, right? Squared.
Oh, that's what I did wrong. Oh my god. I messed up on that part. I did 1 and 2 10.
Yeah. Now here, if you just square the 12 squared is 144 over 10 squared. This 10 times 10, it is 100. How about here? This thing is again 12 over 10, but here we have cube. That is 12 times 12 times 12. It means this. And also it belongs to 10. 10 times 10 times 10, which is equal to, let me just write here. Here we have 144 times 12 over 1000, right? Now, how can we have the same denominator? If you multiply numerator and denominator by 10, 144 times 10 over 1000. All right, Shahina, now we have the same denominators, 1000 on the left, 1000 on the right. And also 144 the same. And if you notice here we have 10, the difference, right? Here we have 12. That's why this thing is less than this number.
Oh, okay, I see. I
Okay?
think I just messed up the 1 and 2/10. So I'm gonna start.
That is question O. For question O, you said O. All right, next. How about this question? Can you do that? 0.8 square root of 0.8 and cube root of 0.8.
Yeah, I think so. I'll try it. Let me see.
Let me just write here. This is P. Here we have square root of 0.8. And here we have cube root of 0.8. Right. The last thing. So what should we put here? Greater than or less than or equal to?
I think. Hold on. Yeah, I think 0.8 is less
So
than.
what should I put here? Tell me, should I put greater than or equal to or less than?
Less than.
It is greater.
Wait, what? Hold on.
Yeah. Okay, Shahina, no problem. If you cannot do this, maybe because of these symbols, you're a bit confused. Okay, this cube roots. We will get back to this again. But just here to give you some idea, maybe here, if you cannot do, you can just use your calculator and compare this. Without using calculator, how do you compare this? Actually, this thing is, here we have 0.8, okay? And that thing is 8/10. Here we have square roots, all right? So, and what can I do here? Here we have 4, right? That thing is, if you simplify this, 2 times 4, 2 times 5, I can write it as 4/5, right? Now, how about this thing? Here we have cube root of 8/10, and I can write it as cube root of 8/cube root of 10. This cube root of 8 means what number's cube is equal to 8? That is 2 actually, because 2 cubed is equal to 8. So here we have cube root of 10. Now here this thing is square root of 4, that's equal to 2. And here we have square root of 5. Okay. Now as you see here, numerators are the same. Numerators are the same. Now we should check here, denominators. 2 is divided by square root of 5. 2 is divided by cube root of 10. So this square root of 5, it is 2 point something. And how about this thing? Also 2 point, but it is square root of, okay, this thing is smaller than cube root of 10. Okay. Is it you, Shahina? Are you trying something?
No.
Okay. All right. Here we have square root of 5. Okay. Here we have cube root of 10. All right. So we have to compare these two numbers. Which one is actually greater here, smaller? The square root of 5 and the cube root of 10. Okay. So maybe using a calculator you can evaluate this, because now, Shahina, what do you think? Which one is greater?
I think. I think oh wait, really?
This one is greater. So actually here, we should put here, what is it? It is less than.
Yeah.
Okay. Actually, Shahina, no problem. You can just have a look, and using calculator, you can compare this. Later, I will teach you something else, comparing these powers. At the time, we can solve this in very, very easy way. Okay, now you have never seen this, I think. That's why it may look a bit, seem difficult for you. All right.
Yeah.
Now, let's see another example, two more examples, and finish our inequality concept. Here, solve the inequalities. Okay. Here we have this inequality. Solving means, again, like equation, we need to leave this x alone on the left-hand side. So this a, here we have 1 over 2x less than 3. If you multiply by both sides by positive number, nothing changes here. How can I eliminate this 1 over 2 from left-hand side? We should multiply both sides by 2, right? The same thing. 2 times 1 over 2, it is 1. So here we have x. 3 times 2, it is 6. So this is the solution. What does it mean? That means that all the numbers that are less than 6 will satisfy this inequality. Okay, on the number line, what are these? Here we have number line, here we have 6. We are talking about all the numbers here less than 6. If you pick, for example, 5 or 4, 0, -1, substitute here, evaluate this thing, it will be less than 3. It means this. How about question B? Here we have 2x is greater than 18. So how can I eliminate this 2 from here? Multiply both sides by half. So here we have half, or 1 over 2 times 2x. Here we have 1 over 2 times 18, right? So these two things cancel each other. We have x, and 1 over 2 times 18, it is 9. That means that all the numbers greater than 9 will be the solution of this inequality. As you see here, inequality has not only 1 or 2 solutions. It has a lot of solutions, infinitely many. Okay, like 10, substitute here. 2 times 10, 20. Is it greater than 18? Yes. 100, 2 times 100, 200. Is it greater than 18? Yes. It is making this sentence a true sentence, right? So that we call this a solution. Okay?
Okay.
The last example about inequality. Can you read the problem?
A chicken pie costs 70 cents. What is the maximum number of chicken pies that one can buy with $5?
Okay. So that says that a chicken pie costs 70 cents. What is the maximum number of chicken pies that one can buy with $5? Assume that you have $5, right? And assume that you can buy maximum X chicken pies. Maximum number of chicken pies, let's say it is X. And for one chicken pie, how much we are paying? 70 cents, right? If you buy X, how much will we pay here for the whole chicken? 70 times X, right? So here we have 70 times X. If you buy X chicken pies, if each one is 70 cents, then we have to pay this amount, right? But now how much do we have? We have $5, right? And here cents, dollars. First we have to convert this dollar into cents. $5 is equal to 500 cents, right? So this amount, the total amount must be less than or equal to 500, right? Because if it is more than $5, we cannot pay that. We cannot afford, because we have only $5 here. So we have to solve this inequality. Now divide both sides by 70. We have 70 times X over 70 less than or equal to 500 over 70, right? These two things cancel each other. Here we have X less than or equal to, cancel each other, and 50 over 7. As this thing is approximately equal to what? 7 point something, let's say 12 or 14 something, right? If you divide 50 by 7. Now question. Shahina, here the question is, what is the maximum number of chicken pies? So possible values of X is, it is 7, 6, 5, anything, right? So what is this biggest number, biggest whole number that is less than 50 over 7?
7, I think.
7, right? Because here on the number line, if you draw this, x can be 0. Here we have 0, right? It can be 1, it can be 2, it can be 3, it can be 4 or 5. Here we have 6, and here we have 7, here we have 8. But where is 50 over 7? 50 over 7 is somewhere here. But they are asking about the maximum number of chicken pies. So maximum we can buy 7. If I buy 7, what will be the total cost? 7 times 70 cents. It will be 7 times 70 cents, right? It is 490 cents, which is equal to $4.90. How much do we have? $5. So is it enough to buy 7?
Yes.
Yes. But can I buy 8?
No.
No, because it will not be enough, right? So maximum, I can buy 7 chicken pies if each one costs 70 cents.
I mean, that's not bad.
Okay?
Mhm.
Good. Shahina, have some rest, okay? After 10 minutes, we will continue.
Oh, it's done already?
Huh?
Time is...
Yeah, it's
Oh.
37 because now we will start new slides. So only like 3 minutes left. Maybe next session we will have a bit longer one, 45 minutes, okay? Have good rest, drink your coffee or wash your face, okay?
Okay.
So see you after 10 minutes.